Do you really understand freezing? You think you understand freezing. You've seen ice your entire life. You put it in your drinks. You've slipped on it in winter. You've watched frost spread across your windshield on cold mornings. Freezing feels ordinary. So ordinary that no one ever stops to think about it. But let me ask you something. What actually happens really happens at the level of atoms and molecules when water turns into ice. Not it gets cold, not it becomes solid, not it changes state. Those aren't explanations. Those are just labels. So what is actually changing? Most people freeze right there. They go silent, or they say something vague. The molecules slow down. The energy decreases. But those words don't explain anything. They're just different names for the same mystery. And here's the unsettling part. Ice isn't some rare laboratory curiosity. It's one of the most fundamental processes on this planet. Weather, seasons, rivers, oceans, life itself, all of it depends on this single transition, liquid water becoming solid ice. And yet we live with it every day without truly understanding why it happens. First, you're wrong about temperature. Before we go any further, we need to clear something up, because almost everything you think you know about temperature is wrong. You think temperature is a thing, a property, something water has, like weight or color. It isn't. Temperature is motion, nothing more. When you measure temperature, you are not measuring heat as a substance. You are measuring how fast molecules are moving, how violently they vibrate, rotate, and crash into one another. That's it. A thermometer doesn't detect warmth or coldness. It detects collisions. Molecules slam into the thermometer. They transfer kinetic energy. The thermometer averages that chaos and shows you a number. Right now, the water in a glass on your table contains molecules moving at wildly different speeds. Some are barely drifting. Others are racing at hundreds of meters per second. Temperature is just the average of all that microscopic madness. So when you cool water, you're not adding cold. Cold is not a thing. It doesn't exist. Cooling is theft. You are removing energy. You are stealing motion from molecules. When the temperature drops, molecules don't suddenly behave differently. They simply move less. They vibrate less. They collide less violently. And that slowing down, that loss of motion, is what allows everything else to happen. Freezing doesn't begin with ice. It begins with motion being taken away. What is water? Really, water seems simple. H2O, 2 hydrogens, 1 oxygen. You learned that in school, memorized it, moved on. But that formula hides something far stranger. At the center of every water molecule is an oxygen atom. Oxygen has 8 electrons, and it wants its outer shell full. It's greedy. It pulls on electrons harder than hydrogen ever could. Each hydrogen brings 1 electron to the deal. They share those electrons with oxygen, forming covalent bonds. On paper, everything looks balanced, but in reality, it isn't. Oxygen doesn't share equally. Because it's more electronegative, it drags the shared electrons closer to itself. So the electrons spend more time near oxygen and less time near hydrogen. That tiny imbalance changes everything. The oxygen end of the molecule becomes slightly negative. The hydrogen ends become slightly positive. Water is not neutral and symmetrical. It is polar. One side is positive, one side is negative, like a microscopic magnet. And that polarity is the key to almost every strange thing water does. When billions of water molecules move around each other, the positive hydrogen of one molecule is attracted to the negative oxygen of another. They don't merge. They don't form permanent bonds. But they reach. This attraction is called a hydrogen bond. It's much weaker than the bonds holding the molecule together, but it's strong enough to matter specially in huge numbers. And there are huge numbers. In a single drop of water, there are trillions upon trillions of molecules, all reaching, forming hydrogen bonds, breaking them, reforming them, an invisible web of attraction constantly rearranging itself. This is why water behaves unlike almost any other substance. Its high boiling point, its surface tension, its ability to dissolve life's chemistry, and ultimately, the way it freezes. Water isn't just H2O. It's a molecule with imbalance built into its structure, a molecule designed by quantum mechanics to attract its neighbors. And once those attractions are allowed to take control, everything changes. Hydrogen bonds, the invisible threads holding water together. Every water molecule carries a quiet imbalance. The hydrogen side is slightly positive. The oxygen side is slightly negative. And in physics, opposite charges don't ignore each other. They reach. When the positive hydrogen of one water molecule drifts close to the negative oxygen of another, an attraction appears. Not a full bond, not a merger, just a pull. This attraction is called a hydrogen bond. And it's important to understand what it isn't. A hydrogen bond is not the bond that holds a water molecule together. Those covalent bonds are strong. Break one, and you destroy the molecule. Hydrogen bonds are different. They are about 20 times weaker. They form easily. They break easily. They are fragile. But fragility doesn't mean insignificance, because water doesn't contain a few hydrogen bonds. It contains astronomical numbers of them in a single drop of water. Trillions upon trillions of molecules are constantly reaching toward one another, forming hydrogen bonds, breaking them, reforming them millions of times per second. An invisible, shifting network of attraction fills the liquid. You never see it. You never feel it directly. But it is always there. And it changes everything. Hydrogen bonds are the reason water boils at such a high temperature compared to similar molecules. They're the reason water has strong surface tension, forming droplets instead of mist. They're the reason water can dissolve the chemistry of life. And most importantly, they're the reason water freezes the way it does. Individually, hydrogen bonds are weak, but together, acting in vast numbers, they become dominant. They are quiet forces, subtle forces. But when motion slows down, when thermal chaos weakens, these invisible threads finally get their grip. And once they do, water is no longer free to behave like a liquid. Structure begins to emerge. Liquid water, a war between motion and attraction. Liquid water is not calm. It only looks calm from far away. At the molecular level, liquid water is a battlefield. At room temperature, water molecules are moving fast. They vibrate. They rotate. They slam into one another from every direction. And at the same time, hydrogen bonds are constantly trying to pull them together. Every moment, a hydrogen atom drifts close to a neighboring oxygen. A hydrogen bond forms. Attraction wins briefly. Then motion strikes back. Thermal energy rips the molecules apart. The bond breaks. The molecules tumble away, collide with others, and form new bonds somewhere else. Bond. Break. Bond again. This happens in picoseconds, trillionths of a second. No molecule stays connected to the same neighbors for long. No pattern survives. No structure lasts. This is what liquid really means. A liquid is not defined by being wet or flowing. It's defined by competition. Attraction is always present, always trying to organize molecules into structure. But motion is stronger. Kinetic energy keeps winning. The molecules have enough energy to escape any bond that tries to hold them in place. They are too fast, too restless, too chaotic. So water remains fluid, flexible, able to flow, pour, and change shape. Liquid water is not ordered. It's temporarily connected chaos. A constantly shifting network of bonds that never settle, never lock, never stabilize. And this balance, this fragile war between motion and attraction, is the only reason water behaves the way it does. But that balance is not guaranteed. Remove enough motion, slow the molecules down just a little more, and the war changes. Attraction stops losing. And that's when liquid water begins to disappear. When energy falls away, now start taking energy out. Not suddenly, not dramatically, just slowly. As heat is removed, water molecules begin to lose motion. They vibrate less. They collide less violently. They no longer have the strength to instantly tear themselves free. Hydrogen bonds still form, but now they last longer. At first, only briefly, small clusters appear, then vanish. A few molecules hold together for nanoseconds before motion pulls them apart again. But as the temperature drops further, those clusters grow. They survive longer. More molecules join. Attraction is no longer losing immediately. What was once chaos begins to hesitate. The liquid hasn't frozen yet, but it's no longer fully free. You're watching the balance shift. Motion is weakening. Attraction is gaining ground. And once that shift passes a critical point, the liquid can no longer defend itself. Structure is about to take over. 0C. The balance point. At exactly 0C, something extraordinary happens. The kinetic energy of water molecules, their motion precisely balances the energy of hydrogen bonds, pulling them together. Above OC, motion wins. Molecules break bonds faster than they form. Water remains liquid. Below OC, attraction wins. Hydrogen bonds hold fast. Molecules lock into place. This isn't arbitrary. It's not a human decision. It emerges naturally from physics. The mass of oxygen and hydrogen atoms, the strength of covalent and hydrogen bonds, the geometry of the molecule. OC is a knife edge, the tipping point where motion and attraction reach perfect equilibrium, the point where liquid water and solid ice coexist, each fighting for dominance. Why ice forms a tetrahedral structure. When water freezes, the molecules don't just lock wherever they happen to be. Each water molecule can form 4 hydrogen bonds, 2 through its hydrogens, 2 through its oxygens, lone electron pairs. Physics has an answer: geometry and energy. The lowest energy, most stable configuration for these 4 bonds is a tetrahedron, a 3-dimensional pyramid with 4 corners. 2 bonds reach out to the hydrogens, 2 accept to the oxygen lone pairs. The angle between them is dictated by quantum mechanics and electron repulsion. This arrangement is perfectly rigid, beautifully symmetrical, not space efficient. The lattice forms a repeating pattern full of tiny gaps. These empty spaces are why ice is less dense than liquid water. This simple geometric inevitability explains why. Ice floats on water. Lakes freeze from the top down. Fish survive the winter. Life persists. Imagine if ice sank instead. Rivers, lakes, even oceans would freeze from the bottom up. The world as we know it, life itself, would be impossible. The tetrahedral structure isn't arbitrary. It emerges directly from the properties of the water molecule, its shape, its bonds, its electrons. Change those properties, and the ice would be different. But they are fundamental constants of the universe. Every crystal of ice, every snowflake, every frozen lake is a perfect manifestation of molecular geometry, rigid, elegant, and inevitable. Freezing releases energy. When water freezes, something surprising happens. It releases energy. That might sound backwards. You put water in the freezer to make it cold. How can freezing make heat appear? The answer is in hydrogen bonds. As molecules slow down and lock into place, each hydrogen bond forms and releases a tiny packet of energy. The molecules move to a lower energy state, like a ball rolling downhill. When trillions of molecules form stable hydrogen bonds at once, all those tiny packets add up, about 334 joules per gram of water. This is called the latent heat of fusion. It's why ice keeps your drink cold for so long. The ice can't warm up until all that released energy is absorbed. Freezing isn't just cooling. It's molecules reorganizing into a lower energy structure, dumping energy into the environment as they do it. So, why does water freeze? Ice is not ordinary. It is the inevitable outcome of quantum physics, electron behavior, electromagnetic forces, geometry, energy. A single ice cube in your hand is not just frozen water. It is a manifestation of the fundamental laws of the universe, crystallized into a rigid, elegant lattice. It exists because molecules slow down, hydrogen bonds lock in, and the geometry of the water molecule forces them into a tetrahedral pattern. Every ice cube, every snowflake, every frozen lake emerges from these same unchanging rules. Holding ice in your hand is holding the physics of the cosmos itself.